Welcome once again to Mathematics Mirror. In this series, we are going to look at various questions for Year 1 student. That's why we tag this series Year 1 series. Alright, if you're a Year 1 student, this is for you, especially for those of you that are offering mathematics in their first semester and also in their second semester. Alright, let's begin. We have a question already. In this series, we'll be solving different questions from various Year 1 textbooks and also past questions. Okay, now we have the first question we want to consider. If x plus y is equal to 12 and xy is equal to 27, we have to find the value of x raised to the power 3 plus y raised to the power 3. That's x cubed plus y cubed. Now this question looks like question on simultaneous equation, one linear, one word, one quadratic. That's what it looks like. But we're not going to use that approach to solve it. We'll not be, solving this simultaneously, finding x and y, and then we don't substitute the values of x and y here. No, we will not take that approach. I'm going to show you what we are going to do. Okay. Now, is it possible for us to express x cubed plus y cubed in terms of x plus y and xy, so that we can just substitute the value of x plus y, which is 12, and also substitute the value of xy, which is 27? Yes, it is possible to do that. And how can we do that? We just remember an expression for sum of root of cube, sum of cube. That's what we remember, expression for sum of cube. Now we know we can write this in alternative form. If I do x plus y all raised to the power 3, a binomial expansion, I know I'm going to arrive at x raised to the power 3 plus 3x squared y plus 3xy squared, then plus y raised to the power 3. And from there I can have that x cubed plus y cubed, that's this, is equal to x cubed plus y cubed plus 3x squared y plus 3xy squared, which I can also write, you know what I did, I just brought this closer to this, which I can also write as x cubed plus y cubed plus 3xy bracket x plus y close bracket. Okay, that's x plus y all raised to the power 3. That means I can make x cubed plus y cubed the subject of formula. I can do that. And if I do that, I'm going to have x plus y all raised to the power 3 is equivalent to, okay, let's bring this here. We have minus 3xy bracket x plus y is equal to x cubed plus y cubed. I just brought this to this side. I've made this the subject of formula. Rewriting this, I can have that x cubed plus y cubed is equal to what? X plus y all raised to the power 3 minus 3xy bracket what? X plus y. Now you notice that I've expressed x cubed plus y cubed in terms of x plus y and xy. If you look at this now, we have x plus y, right? xy, x plus y. And then we know the value of x plus y, which is 12. We know the value of xy, which is what? 27. So if we substitute that, we can solve our problem. Thus, I can write that x cubed plus y cubed from what we have done there is equal to x plus y all raised to the power 3 minus 3xy bracket what? Bracket x plus y. Okay? So what's the value of x plus y? X plus y is 12 given to us, so I can write this as 12 raised to the power what? 3 minus 3 times, what is xy? 27. And what is x plus y? Still 12. Okay? If we decide to raise this to the power of 3 and multiply this, we'll be having very high numbers. So in order to reduce the number, we can look at this and factor 12. 12 is common here, we have 12 here, we have 12 cubed here. So if I factor 12, I'll be left with 12 raised to the power 2 because I just factored one of the 12 minus 3 times 27 because this 12 is also gone. Yeah. So that will give me 12 bracket. 12 raised to the power 2 is 144 minus 3 times 27 is 81. Okay. So we have 12. 144 minus 81 will be giving us around and 6, so 63. And when we now use 12 to multiply 63, what are we going to have? 12 times 63 will be giving us 756. Don't ask me why I did that very fast. This is what I did in my mind immediately. 63 times this is 630, and 63 times this is 126. That was what I was doing there. So we have 6, 5, and 7. So 756. All right. As you are enjoying this one, just get ready for the next question. Bye.